students, let's do Playing with Numbers Revision 2. So here the first question is true or false. You need to write whether these statements are true or false. So first work it out and then you can check your answers with me. Question 1. A number cannot be both even as well as odd. Is that true or false? That is true, isn't it? So let's write true. That statement is true. You can't have a number which is both even as well as odd. Next one, 1 is a unique number. Yes, 1 is a unique number. It is neither prime nor composite. So we give it a special name, unique. Unique number means a special number. So this statement is also true. Question 3. 520 is divisible by 4. Now what is the test for 4? You see the last two digits and see what number it forms. The last two digits here forms 20 and 20 is divisible by 4. So this statement is true. 520 is divisible by 4. See, we did that without even doing actual division, isn't it? That is why we use the test of divisibility. Question 4. 72,533 is divisible by 3. Now what is the test for 3? The test for 3 is we need to add up all these digits and see what we get. Now let's try that. 7 plus 2 plus 5 plus 3 plus 3. Let's see what we get. 7 plus 2 is 9. 9 plus 5 is 14. 14, 15, 16, 17, 18, 19, 20. So we get 20, and as you can see 20 is not in the tables of 3. So this statement is false. The statement said that that number is divisible. It is not divisible. So this statement is false. Question 5. A number is divisible by 9 if the sum of its digits is divisible by 3. That statement is false. A number is divisible by 9 if the sum of its digits is divisible by 9 and not by 3. So this statement is also false. Okay, now let's go on to the next statement. A number is divisible by 15 if it is divisible by 3 and 5. That statement is true because 3 5s are 15. So if a number is divisible by 3 as well as by 5, then we say that that number is divisible by 15. So this statement is true. Question 7. A number is divisible by 18 if it is divisible by 2 and 9. 2 9s are 18. So if a number is divisible by 2 as well as by 9, then we say that that number is divisible by 18. That statement is true. Question 8. A natural numbers are numbers that start from 1. A natural number that is divisible only by 1 and itself is called a composite number. Is that true? No. A number that is divisible by only 1 and itself is called a prime number. Okay, so this statement is false. So let's write false there. Question 9. 1 is not a prime number. That statement is true. It's neither prime nor composite. It is a unique number. So this statement is true. The H.C.F of two co-prime numbers is always 1. What are co-prime numbers? Co-prime numbers are two numbers that don't have any common prime factor between them. And the H.C.F of such numbers is always 1. So this statement is true. Question 2. Find the greatest number that can divide 34, 196 and 119 completely. So whenever a question like this comes, the greatest number, then we say we have to find the H.C.F of these three numbers. Okay, so the greatest number that can divide these three numbers completely is its H.C.F. So let's start working. So the first step, the greatest number that can divide these three numbers completely is its H.C.F. Now there are many methods to find the H.C.F, and the easiest will be to use the common division method, the long division method. Okay, So especially when you have slightly bigger numbers like 196 and 119, three-digit numbers, it's always easier when you use the long division method. So let's begin. Now let's take the first two numbers, 34 and 196, and let's divide. So we are dividing 196 by 34. Now we have to get a number close to 196. So let's multiply 34 into 5 and see what we get. Okay, so 5 4s are 20, carry 2, 5 3s are 15, 16, 17. Yes, we can write 170. So 34 into 5 is 170 minus 6. 9 minus 7 is 2. So we have 26. Now once again inside our sign here, we're going to put 34 and 26 is our new divisor. So 26 ones are 26 minus, now here again I'm going to borrow 14 minus 6 is 8. So I'm going to put 8 outside as my divisor and 26 here. Now 8 threes are 24 minus, now let me subtract. 6 minus 4 is 2. Then we have 0 and then now I'm going to put 8 inside. 2 4s are 8. So we've got a remainder 0. So our last divisor is 2. The last divisor that gave us this remainder 0 is what we are going to use with the next number. So the next number is 119. So let's divide 119 by 2. So we have 119 as the dividend inside and we have 2 as the divisor. So first let's divide this. Okay, so 2 5s are 10 minus 19, 2 9s are 18 minus we have 1. Now we put 1 outside and we put 2 inside. So here we get 1 2s are 2. Now we minus, we get the remainder 0. So which is our last divisor here? The last divisor is 1, which gave us the remainder 0. So that is the H.C.F. So let's write that down. The H.C.F of these numbers 34, 196 and 119 is 1. So the answer is 1 here. Question 3. In this, the first one, find the LCM of 12, 15 and 10 by the common multiple method. Multiple method means we write the multiples of these numbers and find a common one. Okay, so let's begin. So here, first we have to write the multiples of 12. So let's write a few multiples of 12. 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 fives are 60, 12 six are 72. Okay, so we'll stop with that. There are many more to go. In case we don't find a common one, we'll write a few more. Next, we write the multiples of 15. 15 ones are 15, 15 twos are 30, 15 threes are 45, 15 fours are 60, 15 fives are 75. So let's stop with this and go on to the next one. Multiples of 10. 10, this is easy, isn't it? 20, 30, 40, 50, 60 and so on. Then now we have written, the first thing that we did is we wrote the multiples of 12, then we wrote the multiples of 15, then we wrote the multiples of 10. Now we have to pick a common multiple here. Okay, so let's go ahead. Common multiples. So look and see which number is common. We have 12, 24, 36, 48. Do we have any of these here? No. As you can see, multiples of 10 are all ending in 0. So look for a number that's ending in 0. So here if you look, we have 60. Now see if you have 60 here. Yes, here we have 60. So here also we have 60. So that means 60 is a common multiple. So 60. So let's write down 60. So 60 is one common multiple. Now if you carry on, if you continue to write this and the multiples of 15 and the multiples of 10, you will find many more common multiples. Okay, you will find many more common multiples like 60. But here we are looking for LCM, that means the least common multiple. We're looking for the smallest common multiple. So the first multiple that you write will be the smallest common multiple. Okay, so the least common multiple is 60. So that is our answer. So there is no need for us to write many more multiples. We are just looking for the smallest, and that's the first one that we write. Okay, now before we carry on with the next step, I want to write down the prime numbers between 1 and 100. This is something all of you should know by heart, and you'll be able to answer any question on prime numbers if you know this. Okay, so these are all the prime numbers between 1 and 100. There are 25 prime numbers, and I've put them in such a way that it's going to be easy for you if you can remember this picture in your mind. So if you can see in the first row, I have only the one-digit numbers, 2, 3, 5, 7. Okay, now if you're asked questions based on this, the first row you can answer, fill in the blanks, true or false. Which is the smallest prime number? 2. Which is the only even prime number? 2. How many one-digit prime numbers are there? 1, 2, 3, 4. 4. Which is the smallest odd prime number? 3. Okay, so the first row will give you the one-digit prime numbers. After that, you have all two-digit prime numbers. And here also I've arranged them in a particular way. So look at the second row. If you look at the second row, you can answer questions like, which is the smallest two-digit prime number? 11. Okay, then here I have the prime numbers between 20 and 30. 2, between 30 and 40, 2, between 40 and 50, 3, between 50 and 60, 2, 60 and 70, 2, 70 and 80, 3, 80 and 90, 2, and between 90 and 100 there's only 1. And this is the largest two-digit prime number. So if you can learn this whole table by heart, it will be good. Keep this picture in mind so you can answer any question. Okay, suppose they say, what are the prime numbers between 40 and 50? If you can remember this picture in mind, you can quickly write 41, 43, 47. What are the prime numbers between 70 and 80? 71, 73, 79. So this is a useful table. Okay, now let's carry on with our other questions. Question 2 here. Find the LCM of 40, 56 and 60 by the common division method. So in the common division method, we have to make use of prime numbers. So let's write down a few prime numbers. 2, 3, 5, 7. I've written only the one-digit prime numbers. Now let's begin the common division method. So first step is we write down the numbers. So we have 40, 56 and 60. Now we're going to divide all these. Now let's divide this by, say, 5. We can start with 5 itself. Okay, so 5 eighths are 40. 56 I can't divide, I bring it down. Now 5 twelves are 60. Okay, 12 fives are 60. Now we continue. Now I can use 2. Okay, so let's do that. 2 fours are 8. Now 56 divided by 2. Now if you're not sure, we can do short division and get that answer. So 2 twos are 4. What is left is 1. Now that number is 16. 2 eights are 16. So 2 into 28 is 56. 2 sixes are 12. Now let's continue. Again, I can divide by 2. So here 2 twos are 4. Now 2 into what is 28? Again, I can divide 28 by 2 and find out. 2 ones are 2, 2 fours are 8. So 2 into 14. Then here we have 2 threes are 6. Now let me continue my division with 2. So here I have 2 ones are 2, 2 sevens are 14, and I bring down 3. So now the numbers left are 7 and 3. Let me use 3 and divide. So here I have 1, then I bring down 7, 3 ones are 3. So what is left is only 7, so I can use that. Okay, so I have 1, 7 ones are 7 and 1. Now my LCM. Okay, I'm going to use all these numbers. Let me count how many 2's are there first. 1, 2, 3. So there are 3 2's. Let me write the 2's first. 2 into 2 into 2. Then let me write the 3. So there's 1, 3. Then let me write 5. So 1, 5 there. And into the last one is 7. So if I multiply all these, I will get my LCM here. Okay. So let me multiply all the 2's first. 2 2's are 4, 4 2's are 8. So 8 into, I can multiply this. 5 3's are 15 into 7. I'm doing this just to make my multiplication easier. So let me multiply 8 into 15. So 15 into 8. 8 5's are 40, carry 4, 8 1's are 8, plus 4, 12. So that's 120 into 7, into 7. 7 zeros are 0, 7 2's are 14, carry 1, 7 1's are 7, plus 1, 8. So I have found my LCM. My LCM is 840. So this is my final answer. Question 3. Find the least number which when divided by 15, 30 and 90 leaves no remainder. So least number means LCM. L stands for least, isn't it? So let's do that. The least number which when divided by 15, 30 and 90 leaves no remainder is its LCM. So we are going to find the LCM of these numbers. So what are the numbers? I have 15, then 30 and 90. So let's find the LCM. Now let me use 3. Okay. So here I have 3 5's are 15, 3 10's are 30, then 3 3's are 9. So 3 into 30 is 90. Now I'm going to use 3 again. I can continue. So I will bring down 5 as it is. I'll bring down 10. Then 3 10's are 30. Now I can divide by 5. So that will be 5 1's are 5, 5 2's are 10, 5 2's are 10. So now I can use 2. So I bring down 1, 2 1's are 2 and 2 1's are 2. So now I can write my LCM. So I have 1 2, I have 2 3's and I have a 5. Okay, so 3 3's are 9. So 2 into 9 into 5. 2 9's are 18. Now let me find 18 into 5, how much it is. 18 into 5. 5 8's are 40, carry 4. 5 1's are 5, plus 4 is 9. So my LCM is 90. So this is my answer. LCM is 90. Question 4. Find the least number which when divided by 12, 16, 24 and 36 leaves a remainder 6 in each case. So least number means LCM, but here it says this time it's leaving a remainder 6. So let's be careful with that. So first let's begin to find the LCM. So the least number that can divide 12, 16, 24 and 36 is its LCM. So let's begin to find the LCM of 12, 16, 24 and 36. So let's begin with 3. So 3 4's are 12, 16 is not divisible, so I bring it down. 3 8's are 24, 3 12's are 36. I'm going to continue to divide with 3. So that will be 4 I bring down, 16 I bring down, 8 I bring down because these are not divisible by 3. Now 3 4's are 12. Now I'm going to divide with 2. So that will be 2 2's are 4, 2 8's are 16, 2 4's are 8, 2 2's are 4. Again I divide by 2. So that will be 2 1's are 2, 2 4's are 8, 2 2's are 4, 2 1's are 2. Continue with 2. Again it becomes 1, 2 2's are 4, 2 1's are 2 and 1. I have to divide once more by 2. So that is 1, 2 1's are 2. Now they're all 1. Now let me find the LCM. So let's count how many 2's there are. 1, 2, 3, 4 2. So let's write down the 4 2's. 2 into 2 into 2 into 2. Now how many 3's are there? There are 2 3's. So that will be into 3 into 3. 3 into 3. So here let's multiply the 2's. 2 2's are 4, 4 2's are 8, 8 2's are 16 into 3 3's are 9. So we have to multiply 16 into 9. 9 6's are 54, carry 5, 9 1's are 9 plus 5 14. So my LCM here is 144. So this is our final answer. LCM is 144. So we found the least number. Okay, so that is we found the LCM. Now it says it leaves a remainder 6. So what should we do with this 144? Now we take 144 and add 6 to it. It leaves a remainder, isn't it? Add 6 to it. So 6 plus 4 is 10. Carry 1. 4 plus 1 is 5. Plus 1, 150. So 150 is my final answer. This is the least number which when divided by these numbers will leave a remainder 6. Now you can check it. You can take 150 and divide it by 12. You will get a remainder 6. If you divide it by 16, you will get a remainder 6. If you divide it by 24 and by 36, you will get a remainder 6. You can check your answer that way. Okay, so our final answer. LCM is not a final answer. LCM plus 6, 150 is our final answer. Question 5. The product of H.C.F and L.C.M of two numbers is 150. Product means when we multiply. When we multiply H.C.F and L.C.M, you get 150. Now, here it says one of the numbers is 15. Find the other number. So, there's a very important property which says when you multiply two numbers, any two numbers, it is equal to the product of that HCF and LCM of those two numbers. So we're going to keep that property in mind and work out. So the first step, the product of the HCF and LCM of two numbers given to us is 150. What else is given to us? One of the numbers is given to us, which is 15, and we are asked to find the other number, and there is a formula for it. And what is the formula? The formula is HCF into LCM divided by one number will give you the other number. Okay, so HCF into LCM is given to us, the product is given to us as 150. So let us substitute. We're going to substitute all these values here. So 150 divided by one number. What is that one number? It's also given to us 15. Now if you divide these two, you will find the other number. So here 15 ones are 15. 15 into 10 is 150, isn't it? So here we get 10. That means the other number, okay, the other number is 10. Given this, children, you can check your answer. How can you check your answer? You can get this. HCF into LCM is 150 and divide it by 10 and see if you're getting one of the numbers. That will be 15. Okay, so we can get our answer by checking it. The other number to this question is 10. Question 5 is 10. This is the answer. Question 6. The HCF of two numbers is given this time, 40, and the product of the two numbers is given to us. We have to find the LCM. So for this also, there is a way to do it. First, your statements. The HCF of two numbers is 40. The product of two numbers is 3200. Now we have to find the LCM using this formula. The formula is product of two numbers divided by HCF. So when HCF is given, you put HCF down. You divide it by HCF to find LCM. If LCM is given, you put it down to find the HCF. So same formula to find HCF or LCM. It will just reverse. Instead of HCF, you write LCM. So here, since we have to find the LCM, we put HCF here. We divide it by HCF. So let's do that. Product of two numbers is given to us 3200. The HCF is given to us 40. Now let's divide these two to find the LCM. So I can cancel here. I can also divide 320 by 4. 4 8s are 32 and I put the 0, that's 80. So here I've got 80. That means my LCM, I have found my LCM here to be 80. So this is my answer. So the LCM of the two numbers is 80. So children, with this we end today's revision. Thank you, children.